Okay, so for lesson for ELEC 2, Advanced Electronics, it's about audio electronics. So the learning objectives is describe the purpose of amplifier, identify the three basic configuration of transistor amplifier circuits, identify the classes of amplifier, describe the operation of direct coupled amplifiers, audio amplifiers, video amplifier, radio frequency amplifier, RF amplifiers, and operational amplifiers. So, then draw and label the schematic diagram for the different types of amplifiers. So when we are talking about the amplifier are electronic circuits that are used to increase the amplitude of an electronic signal. So a circuit designed to convert the low voltage to a higher voltage. That's what the amplifier do. And a circuit designed to convert low current to high current is called a current amplifier. So the course content of this module is the amplifier configuration, amplifier biasing, and amplifier coupling. So in order for a transistor to provide the amplification, it must be able to accept an input signal and produce an output signal that is greater than the input. Okay, so sa mga binigay natin example before, sa isang transistor, okay, sa isang transistor, meron kang input signal dito. Okay, so pag nagkaroon ka ng input signal, syempre dumodoble yan dito sa nilalagay mong input sa collector. So, when it comes to amplification, dumodoble siya kasi meron kang additional na input coming from this side. Although maliit lang siya, pero ayun yung ginagawa niya. Example lang din sa amplification, pag more voltage or current, nilalagay mo dito sa may base, okay, mas lumalakas din yung nagpo-flow na current from the collector to emitter. Yan. So, yan. Nag-usapan na din natin din siya ng advance, pero ito siya. Itsura niya. So, the input signal current flows in the transistor. So, this turn, yan. In turn, controls the voltage through the load. So, ito, dito papasok yung load. So, the transistor circuit is designed to take voltage from the internal power source or dito sa nanggagaling kay VTC and apply to a load resistor in the form of an output voltage. So the output voltage is controlled by a small input voltage. Ayan, dito. So ulitin natin, pag naglagay ka ng input voltage coming from the base, ito, lumalabas yan, ito. Collector to emitter. Ikot na ulit yan. And then, voltage out. Yan. So, however, there is more than one way of achieving this amplifying or amplification or amplifying device. The transistor can be connected into three different circuit configurations. So, in each configuration, one of the transistors leads serve as a common reference point and the other leads serve as input and output connection. So each configuration can be constructed using their NPN or PNP. So yung three configuration na meron tayo ay common base, common emitter, and then common collector circuit. So in each transmitter's emitter base, junction is forward bias, while the collector base is reverse bias. Each configuration offers advantage and disadvantage. So pag nag-usapan natin si common base amplifier circuit, ayan. So, ito yung pinaka-common niya, si base, common base, common base. Ito kasi yung shared niya from the inputs. Meron dito and ito. Okay, so the input signal enters in the emitter base circuit. Ayan. Emitter base circuit, the input signal. And leaves from the collector base circuit, which is ito. Ulitin natin. Emitter base and mag-leave siya kay collector base. So the base is the element common to both circuit and both in the input and the output. Ulit natin, magpo-flow. Ito yung base. Magpo-flow yan here. Punta dito. Ito si capacitor, load resistor. So ulitin natin, kaya common base, okay? The input signals enter in the emitter base. Yan. So yung signal na pinasok mo, emitter, and leaves from the collector base. Ayan. So, ulitin natin. Ayan. Once na nag-flow si current here. Ayan. Ito si load resistor. Nag-flow from here. Kakaroon siya ng input. Ito yung flow niya. Ayan. So, dito. Mag-store kay capacitor din. Lalakas. Magkakaroon siya ng amplification here. Next, a common emitter amplifier circuit. So, in the common emitter circuit, the input signal enters the base emitter circuit. Okay, so kanina, emitter base. Yeah, emitter base. Now, dito, okay, common emitter, ang pinaka-common nila kasi yung nag-share current ay dito, kay emitter. Kung mapapansin nyo, kaduktong. So, in this configuration, the input signals enter from the base emitter circuit. Ayan. Enter. And the output signal leaves from the collector. So, ang nangyayari naman, dito papasok signal. Ayan. So, ang nagiging common niya is yung K-emitter. So, the emitter is common to both the input and output circuit. So, this method is connecting a transistor is widely most used. Sorry. Ayan. So, ulitin natin, and yung flow. Once connected, ito, si switch, magkakaroon ng flow here. Para mag-open si emitter as a gate, si load resistor, may mag-flow na VCC. Ayan, here. Ang pupunta kay capacitor, may ipon siya. Then, lalabas kay output na. Ayan. So, the common collector amplifier circuit. So, the third type of the connection. Okay, the common collector circuit in this configuration. The input signals enter from the base collector. And the output signal leave from the emitter collector. Okay, so anong nangyayari naman dito? The collector is the common the collector is the common both the input and output circuit. So this circuit it is used as an impedance matching circuit. Yan. So anong nangyayari naman ulit dito? Ulitin natin. Common collector circuit. The input signal ay nag-enter kay base collector. Yan. Flow naman siya here. Base collector. And then, leaves from the emitter collector. Emitter and collector. Emitter and collector. So, ginagamit siya for impedance. So, yung flow naman niya, base, collector, ayan, and then leaves from the wave flow. Ayan, emitter, collector. Ayan. Ulitin natin, ginagamit siya for impedance matching circuit. So, the amplifier circuit characteristics ay makikita dito sa table na to. So, the filtered current and power gains for the three circuit configurations. So, in the common base, the input resistance is low, the output resistance is high. Yung voltage gain niya is high, current gain is less than 1. Yung power gain is medium. Common emitter, medium, 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 and then power gain is high. So, ito yung commonly used. So, dito, ginagamit lahat ng pagkataas ng example, yung gagawin yung amplifier, ayan, from the microphone, nagkakaroon ng malakas ng volume. So, the common collector, ginagawa siyang impedance matching circuit. So, high, low, less than 1, medium, then medium. Yan. So, kung titignan yung table dyan from the amplifier type, so the input waveform, so they have the same or low, and then yung output nila. So, sa common collector, kung titignan nyo, yung same lang niya. Dahil si impedance matching is designed sort and load impedance to minimize the signal reflection or maximize power transfer. So, ulitin natin na minimize na yung signal reflection. So, sa circuit na to, the source and the load should be equal. Kaya yung input waveform is and the output waveform is same. In ano yan, sorry, in DC circuit. In DC circuit, when the impedance matching circuit should be equal from the source and the load. In the alternating current circuits, the source should either equal the load or complex conjugate of the load, depending on the goal. So, within natin, in this figure, the phase relationship on input and output waveform for the three configuration. So, kung titignan natin sa common emitter configuration, provides phase reversal of the input-output signal. Ayun yung nangyayari. Meron siyang phase reversal. So, in amplifier biasing, the basic configuration of transistor amplifier circuit are common base, the common emitter, and the common collector. So, all of them require a 2 voltage for proper biasing. Dun sa may base emitter junction must be forward bias and the base collector junction must be reverse bias. However, yung both bias voltage can be provided from a single source. So based on the pag-usapan natin, the common emitter circuit configuration is the most often used. So it is described here in the amplifier biasing. So the same principles apply to the common base and common collector circuit. So yeah. The common emitter amplifier is a single voltage source. So yung single voltage source niya, wala. The voltage current collector or collector current yan, TC. So it shows the emitter transistor amplifier is a single voltage. So mapapansin nyo, ayan. And then, reverse bias and then forward bias. So ulitin natin, pag forward bias, positive, and reverse is negative. So the circuit is schematically diagrammed. So the voltage source is identified as a plus VCC. Ayan, plus VCC. So the symbol ground is the negative side of the voltage. So here in the amplifier biasing, the basic configuration of transistor amplified circuit are the common base, the common emitter, and the common collector. So all require 2 voltages for proper biasing. So the base emitter junction must be forward biased and the base collector junction must be reverse biased. However, both bias voltage can be provided from a single source. So because of the common emitter circuit configuration is the most often used, yun yung ipapakita natin here. So, the same principles apply to the common base and the common collector circuit. So, in amplifier biasing, the common emitter amplifier is a single voltage source. So, Yun yung galing C, VCC. So here is the schematic diagram. The voltage source is identified as VCC here. So the ground symbol is the negative side of the voltage source, so negative side. Ng VCC, positive, negative. So the single voltage source provides proper biasing for the base emitter. Ulit natin, the single voltage provides proper biasing here, K, base and emitter. Base emitter. And syempre, same as K, base collector. Base collector, proper biasing. So the two resistors, RB and RL, are used to distribute the voltage for proper operation. So yung resistor RL or yung load resistor, the collector load resistor in this series is the collector. Ayan, kasiris yan. Nakatingin siya kay collector. When a collector current flows, a voltage develop across the resistor RL. So the voltage drop across resistor RL and the voltage drop across the transistor collector emitter junction must add up at the total voltage applied. So dito, magkakaroon siya ng voltage drop and then when lumabas na siya kay collector emitter, adding kay base emitter, yan. Nag-add na yung total voltage applied. So si RB naman connected between the base and the voltage source. So hindi natin connected siya kay base and then kay voltage source. So in the resistor RB controls the amount of current flowing from the base. That's why the base current flowing through the RB creates voltage across it. Most of the voltage from the source is dropped across it. So a small amount of voltage drop across the transistor base to emitter junction provides the proper forward biasing. So the single voltage source can provide the necessary forward bias and reverse bias to the voltages. So for NPN transistor, the transistor base and collector must be positive with the respect to the emitter. Therefore, the voltage source can connected to the base and the collector. Yan. Through the resistor RB and RL. So this circuit is often called base bias. Base bias. Yan. Base bias circuit because the base current is controlled by the resistor RB and the voltage source. So the input signal is applied between the transistor's base and emitter or between the input terminal and ground. So the input signal either aids or opposes the forward bias across the emitter junction. This causes the collector current to vary, which then causes the voltage across RL. Ayan. To vary. So the output signal is developed between the output terminal and ground. Ulitin natin, the output signal is developed when between the output and the terminal ground. Yan. So yeah, in this figure, the temperature changes cause the transistor internal resistance to vary, which cause the bias current to change. So this shift the transistor operating point, reducing the gain of the transistor. This process is referred to as thermal instability. So, in that figure is unstable because it cannot compensate for the change in the bias current with no signal applied. So, pag sinabing thermal instability occurs when the junction temperature and the collector current increase in regenerative and uncontrollable fashion. So, yun nga, umiingat kasi si transistor. So, the limit depends on the factors both within and the external to the transistor. Sa internal factor ng transistor, meron siyang thermal resistance. So, the current amplification factor and the base lead resistance. So here, in the common emitter amplifier with collector feedback, so sinasabi dito, it is possible to compensate for the temperature change in a transistor amplifier circuit if a portion of unwanted output signal is fed back. So, yeah. So, yung output signal is pag nag-rotate na kasi yan dito, yan. Papunta here sa VCC. Yan. Mga unwanted, babalik kay RB. So, if a portion of the unwanted output signal is fed back to the circuit input, the signal opposes the change. So, this is referred to as degenerative or negative feedback. So, sa circuit in using degenerative feedback, the base resistor is connected directly the collector ng transistor. So, okay, the current flowing to the resistor RB flow is determined by the voltage at the collector. So, nadidetermine daw siya dito sa voltage ng collector. If the temperature increases towards dito kay VCC, the collector current increases. Okay? Yung nagfo-flow dito kay collector ay nag-increase din. And the voltage across RL increases. Okay, ulitin natin. Siyempre, nagfo-flow ng current here. So, pag nag-increase ng temperature, si RL or si load resistor ay nag-increase din syempre. So, the collector to emitter voltage decreases, reducing the voltage applied to the RB. So, dito natin, syempre, pag nag-reduce dito kay collector emitter, yung pumupunta na output kay RB, syempre, is nagdi-decrease. Kaya, lumalabas na output nito ay maliit lang din. So, this reduced the base current which causes the collector current to decrease. So, this is referred to collector feedback circuit. So, common emitter amplifier with the emitter feedback. Yeah. So, sinasabi, an increase in the temperature causes the electric current to increase. So, the emitter current also increase causing the voltage drop across the resistor, RE. Ayan. So, dito. Yung lumalabas din na voltage kay emitter, nagkakaroon naman siya ng voltage drop din dahil naglay ka ng resistor dito kay emitter. So, to increase and the voltage across the resistor RB to decrease. So, this shows the another type of feedback na katulad dito sa isa. Nasaan yung isa? Same as this one. So, the base current then decrease, which reduces both collector current and the emitter current. So, collector current nag-is because the feedback is generated at the transistor emitter. So, the circuit is called emitter feedback circuit. So, this is a problem sa mga ganitong type ng circuit because an alternating input signal develop across the resistor. So, yung RE as well as across the load resistor and the transistor, this reduces overall gain of the circuit. So, here sa emitter feedback with bypass capacitor, okay, so sinasabi kay bypass capacitor, the bypass capacitor prevents any sudden voltage change from appearing the resistor RE. So, pag nagkakaroon ng voltage change kay RE, nandito si bypass capacitor by offering a lower impedance to the AC signal. So, the bypass capacitor holds the voltage across the resistor RE steady while the same time not interfering with the feedback action provided by the resistor RE. So, itong additional capacitor here sa circuit ay tinatawag na bypass capacitor. Ito. So, in this common emitter amplifier with voltage divider, when it comes to voltage divider, yung RB kanina, yung base resistor mo ay pinalitan ng dalawang resistor. So, itong dalawang resistor ay connected series across the VCC. Yan. VCC and then yung flow naman niya dito. Ito yung flow. And this one. Yan. So, the resistor divide the source voltage into two voltage forming a voltage divider. So, si resistor 2 drops less voltage than R1 because the voltage at the base with the respect to the ground is equal to the voltage developed across the R2. So the purpose of the voltage divider is to establish a constant voltage from the base of the transistor to the ground. So the current flow through the resistor is towards the base. Therefore, the end of the resistor R2 attached to the base is positive with respect to the ground. So because of the emitter current flows through the RE, the voltage drop across the RE is more positive at the end that is attached to the emitter. So the emitter base, si emitter and si base junction is the difference between the two positive voltage developed across the R2 and resistor RE. So for the proper forward bias to occur, the base must be slightly more positive than the emitter. And then when the temperature increases, the collector and the emitter also increases. So the increase in the emitter current causes an increase decrease in voltage drop across the emitter resistor. So this results in the emitting becoming more positive with respect to the ground. Okay, syempre dapat daw positive, more positive yung dumaloy dito kay R2. So dapat lesser voltage siya. So the forward bias across the emitter-base junction is reduced, causing the base current to decrease. So the reduction in the base current reduces the collector and emitter currents. The opposite action takes place if the temperature decreases. So the base current increases, causing the collector emitter current to increase. Okay, yun naman yung opposite. Ulitin natin, pag si temperature naman ay nag-decrease, here, coming from here, yung dadaloy naman kay Rn R2 ay also mag-increase. Kaya, ang mangyayari kay collector and emitter ay nag-increase. In Class A amplifier circuit, the amplifier circuit have been biased so that all the applied AC input signal appears in the output signal. So, except for higher voltage, the output signal is the same as the input signal. So, an amplifier that is biased to the current flow through the entire cycle is operating an Class A circuit. And then, in the Class AB amplifier output, the amplifier that is biased, so the output current flows for less than a full cycle, but more than half cycle is being operated as Class AB amplifier. More than half but less than full AC input signal is amplified in the Class AB mode. Pag Class B naman, amplifier that is biased, so that the output current flows for only half of the input cycle is operating as Class B amplifier. So, ito yung input mo as a flow, then ang output mo ay kalahati lang. So, only one half of the AC input signal is amplified in the Class B mode. So, in the Class A amplifiers, the most linear of the amplifiers, they produce the least amount of distortion. They also have a lower output ratings and the least efficient. So they find wide application where the full signal must be maintained as the amplification of audio signals in radios and television. But still, because of high power handling capabilities ng mga Class A, syempre required sila for the Class A operation. So, the transistors are usually operated in AB class or Class B. So, if maghahanap tayo ng examples, okay, ng Class A amplifier, suitable siya for, yun nga, outdoor musical system. Yan. Kung nakikita nyo yung mga malalaking speaker, yan, sila yun. Kaya nga siya for high power handling capabilities. So, push-pull amplifier system, the Class A, B, C amplifier produce a substantial amount of distortion. This is because they amplify only a portion of the input signal to amplify the full AC. So, ulitin natin. Meron kang input na isang full cycle, but the output, syempre, is kalahati lang. But, yun nga, para makapag-amplify ka pa din ng full alternating current, so, 2 transistors ang kailangan to connect in a push-pull configuration. So, yung mga amplifiers na ganito ay used in minimum distortion. So, yung mga Class B push-pull power amplifier use mainly in equipments requiring high power output and high power efficiency. So, when it comes to Class B amplifier, used as output stage just of stereo system and public address amplifier and in many industrial controls. So, Class C amplifier are used for high power amplifiers and transmitter where only signal frequency is amplified, such as radio frequency carrier used for radio and television transmitter. Yeah. So, in Class C amplifier output, the amplifier is biased so that the output current flows for less than half of the AC input cycle is operating as Class C amplifier. So less than one alternation is amplified in the Class C mode. So in here, in amplifier coupling, to obtain syempre yung mga gate amplification transistor amplifier, pwede siyang ipag-connect together. However, to prevent one amplifier bias voltage from affecting the operation of the second amplifier, a coupling technique must be used. So the coupling method used must not disrupt the operation of either circuit. So all the coupling methods used include resistance capacitance, coupling impedance, uh, transformer coupling, and direct coupling. So resistive capacitive coupling or RC coupling consists of two resistors, one, two, and a capacitor connected, ito, as shown in the figure. So, resistor R3, yan. Resistor R3 is the collector load resistor of the first stage. And the capacitor C1, this one, is the DC blocking and AC coupling capacitor. So, resistor R5 and R6 are the input load resistor and DC return resistor for the base emitter junction of the second stage. So, resistance capacitive coupling is used primarily in audio amplifier. So, kung hahatiin mo sa umpisa, okay, ang input ng second amplifier ay manggagaling dito kay first amplifier circuit. Yan. So, coupling capacitor C1 must have a low reactance to minimize the low frequency attenuation. That's why a high capacitive value to 10 to 100 microfarad is used. So the coupling capacitor is generally an electrolytic type. So the reactance of the coupling capacitor increases as the frequency decreases. So the low frequency limit is determined by the size of the coupling capacitor. So the high frequency limit is determined by the type of the transistor used. So in the impedance coupling method is similar to the RC coupling method, but an inductor is used in place of the collector load resistor for the first stage of amplification. So impedance coupling works just like RC coupling. The advantage is that the inductor has very low DC resistance across the winding. Here. So the AC output signal is developed across the inductor, just across the load resistor. So however, the inductor consumes less power than the resistor, increasing the overall efficiency of the circuit. So the disadvantage of impedance coupling is that the inductance reactance increases with the frequency. So the voltage gain varies with the frequency. So this type of coupling is ideal for single frequency amplification when a very narrow band of frequency must be amplified. So we have a transformer coupling. So transformer can effectively match at high impedance source to a low impedance load. So the disadvantage is that transformers are large and expensive. Here. So in the transformer coupled circuit, the two amplifier stages are coupled through the transformer. So the transformer can effectively match to a high impedance source to a low impedance load. So the disadvantage is that transformers are large and expensive. Like the inductor coupled amplifier, the transformer coupled amplifier is used for a narrow band of frequency. In direct coupled amplifiers provide a uniform current or voltage gain over a wide range of frequency. So these types of amplifier can amplify frequency from 0 Hz to many thousand of Hertz. When a very low frequency or a DC signal must be amplified, the direct coupling technique must be used. Sa mga direct coupled amplifiers provide uniform current or voltage gain over a wide range of frequency. So this type of amplifier can amplify frequency from 0 Hz to many thousand of Hertz. However, direct coupled amplifiers find their best applications with low frequency. So ginagamit lang si direct coupling into a low frequencies. So pag mga low frequency, mas madalas to ginagamit for radio navigations ng mga maritime. So a drawback of direct coupled amplifier is that they are not stable. So any change in the output current of the first stage is amplified by the second stage. So this occurs because the second stage is essentially biased by the first stage. So to improve the stability requires the use expensive precision components. Yep. Thank you for listening.